Hello, welcome to SQL with Python, right? In this video, we'll be looking at working with multiple tables. In this video and the next, for that matter, we'll be looking at multiple tables using SQL joins. SQL joins are really popular in when we talk about structured query language or SQL or SQL. So in the next video, we'll be talking about things like grouping, aggregate, and all of that. So those also bother on working with multiple tables, right? So before we go into it, I think you need the practical background before we look at how you can use Python to implement this, especially focusing on SQLite. So let's imagine that we have sample tables and data like this. Before exploring joins, let's look at the two example tables we will use throughout this section. So look at the customers table. Imagine we have a customer table. You have a business and you have a customer table. So each customer has an ID. Like let's say, assume you have three customers, one, two, three, Alice, Bob, and Charlie. Those are the three customers with their IDs, one, two, three. And then you have an orders table. So when anytime a customer comes, you have order numbers. So you have order ID 101, 102, 103. And of course, the customer that orders also has they also have their customer ID. So you see, there's customer ID here and there's also customer ID here. So they have something in common, although the data don't particularly match. But then that is the essence of doing joins. So you have customer ID 12124, and you have the amount of order 101 is from first customer, that's 250. Interestingly, the first customer, the ID tells us it's Alice. The second customer, the ID tells us it's Bob, but the third customer that places an order, is the customer ID is for that means automatically the person is not Charlie. So it's some customer we don't know about, right? Right now. Maybe the table is bigger, but we're just focusing on these three. So this will really help us to understand the idea of joins, right? So take note that orders.customer ID is equal to 4. Like orders.customer ID 4 does not exist in customers, which helps illustrate join behavior. So if 4 exists here, maybe I mean, this is necessary so that we can understand the joins, because this order for the customer ID 4 does not exist in the customers table. So that means they just don't want. We don't want to. We are not interested in seeing all the customers at this time because, of course, not all customers place order right at the same time. All right. So. Now, maybe if for a particular day, now these are the three customers that have placed the order by the time you got there. So why do we join tables? In relational databases, data is normalized and stored in separate tables to reduce redundancy and maintain data integrity. However, I guess I want to break this apart. Hope that's not trying to do too much. Okay, I think this works. I can do this, but I come here also so I don't have to read lengthy lines. Yeah, got that. I think that works. Mm, okay, we can also do this. All right, this should work. Yeah, so done. So you see that why do we join tables in relational databases, right? Like SQL is a very good example of relational database. That's database in tables and columns, in rows and columns, right? In tables, rows and columns. So in relational databases, data is normalized and stored in separate tables to reduce redundancy and maintain data integrity. However, useful information is often spread across multiple tables. For example, customer details and their orders reside in separate tables. So, I mean, you could actually have a table containing every information. That is what we've been seeing a lot under data analysis, talking about pandas and all that. But of course, even in pandas, we can join tables. I didn't just get to talk about that. I mean, maybe in the future I may have to talk about that, but I don't know. But here, in when it comes when you come to SQL, right? Joins are really important. So to combine relevant data from multiple tables. So in short, right, you want to have separate tables so you don't have everything modeled up, and so you can know if you need something, you just go straight there because if the tables become too large, it will be difficult to manage. So, but of course, you also want to be sure of your primary keys for each table, in case you need to join more than one table at any point in time. So, to combine relevant data from multiple tables, SQL provides join operations that merge from two or more tables based on related columns, right? So, it means before you join two tables, they must have related columns that you can with which you can reference both of them. So, 5.1.3, let's talk about key relationships now. Now, keys and relationships. we have what we call primary key in SQL. A primary key, I've made mention of this a lot. It's a unique identifier for each row in a table, right? It's a unique identifier. It cannot be duplicated. So, where if you have like customer ID anywhere on the on any of the tables you have, separate tables you have, it refers to the customer ID one refers to Alice everywhere you talk about customer ID one, right? Then you have so for foreign key now, it is a column in one table that references a primary key in another, establishing a relationship, right? So a column in one table that references a primary key in another, establishing a relationship. So you see here that the primary key here is 123. Then this is now a foreign key. The customer ID in others table 2 is a foreign key, with which you can reference the initial one. So, right. So foreign key is a column in one table that references a primary key in another, establishing a relationship. So with that, so example is you have the customer ID. So the customer ID key in customers is your primary key, whereas in the customer ID in the orders table is the foreign key referencing customer underscore ID. So just like what you've seen here. So in essence, we are saying customer ID in customers table is primary key. But when you get to the other table, we still have the customer ID. And with this customer ID, you can join it with the first table. But the customer ID in the other table is actually a foreign key, right? Like that. So joins are commonly performed on this primary key, foreign key relationships. So let's talk about some types of SQL joins, some type of SQL joins. So the first thing is the inner join. So this returns rows where there's a match in both tables. So to do an inner join, if there's a match in both tables, then you can do an inner join. And the syntax for that is select columns from table one, then inner join table two on table key. The table key in table one dot key equals table two dot key. So for instance, now look at this. You have so you want to join these two tables together where they are common. So it means automatically you have Alice and Bob with odd amount 250 to 150 orders, right? And that's exactly what we have here. So that's inner join when you have matching keys like that. And the use case is you want to get all customers who placed orders. You want to get all customers who placed orders. That's what that works for. Like that. You want to get all customers who placed orders. Okay, I think I forgot to space this out so it doesn't look like a code, right? So yeah, so get all customers who placed orders. That's what that is used for, and that's why you get Alice and Bob that are common to both. Then you have left join. Or you can also call it left outer join. What this does is it returns all rows from the left table and matching rows from the right table. So non-matching right table columns are null. For instance, here now, so everything you want everything from the left table. So you need all the Alice, Bob, and Charlie, but one and two match for sure. But here now you have Charlie, but you don't have any match for Charlie on the other stable. So that side is going to be null. That's why you have Alice, Bob, and Charlie. Alice and Bob are both on both tables. Charlie is on the second table, so the amount is null because it doesn't exist. So the use case is you want to list all customers and their orders, including customers without orders. So maybe you just want to say, okay, how many customers have patronized us at this point in time that we are looking at? So you just retrieve all the customers, even those that just came to hang around, right? Or maybe they had not placed order by the time you get there. So Alice had placed order of 250, Bob 150, but Charlie has not. But the Charlie is there. So that's a very you want to list all customers and their orders, including customers without orders. That is left join or left outer join. Then there's also right join or right outer join. So right outer join returns all rows from the right table. So the left table is the first table, right? So the left table is the customers table, the right table is the orders table. So for the right outer join now, you want all the customers here whether they have whether they're on the customer's table or not, you don't care because anyway, if it doesn't match, then that will automatically be null. So for right join or right outer join, it returns all rows from the right table and matching rows from the left table. So you pick everything from the right, but anyone that does not exist on the right will have to be on the left will have to be null. So non-matching left table columns are null. Syntax will be select columns from table one, right join table two on table one dot key equals table two dot key. So use cases, you want to list all orders and their customers. So maybe you want to see, which orders do we already have available? You just want to see all of them. So list all orders and their customers, including orders without valid customer information. So when you join the two together, you discover that, we have three orders, another of 250 by Alice, who happens to be in who happens to exist in the left table, and Bob who is also there. But we have an order of 300, but we don't know who the customer is. So you just say, okay, well, it's an order, valid order received. So no, then you may now want to establish the identity of the customer later. So that's what that is for. And we also have we have the full outer join. So full outer join returns all rows when there is a match in either table. So as far as there's a match, so any information that you have from any table, it's like, okay, I think the idea of set theory would have been perfect in describing some of these things. So you see, what's the first one, the inner join is more like intersection. So you can think about that as an intersection. So what is common to the two tables? Then left outer join. I don't know the best word for that, but right outer join will now be like right outer join will be like the union. So anything that appears in any table, we want to have it there. That's full outer join rather. So full outer join returns all rows where there's a match in either table. So you just select columns from table one, full outer join table two on table one dot key equals table two dot key. So the use case is you want to list all customers and orders matched where possible. So we have Alice with order of 250, Bob with order of 150. There's Charlie, but we don't know the order from Charlie. There's an order of 300, but we don't know the person who made the order. So we just want to see all the customers and all the orders, whether we know the orders of the customers or not, or we know the 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 whether we know customer the whether the customer has placed an order or not, or there's an order whose customer we don't know. That's what I was trying to get out. So the interesting thing is that when it comes to I think even right join, right? You're going to see that. Okay, yeah, right join is not supported by SQLite in SQLite, but we know how to. There's a way to go around it. When I get there, I'll talk about it. So in the same way, full outside join is also not supported in SQLite, and it can be simulated, but it can be simulated using union of left and right joins, right? So we can do that. So SQL. The right join is not supported in SQL, but we can use the left outer join that is existing by, and we switch the columns as you're going to see pretty soon. Then there's what is called the cross join. Cross join brings up the idea. If you check my playlist on set theory, we talked about Cartesian product at some point. Cartesian product is pairing all the possible pairs, of set. Like if you have two sets, the Cartesian product of the two sets is you matching all the possible pairs like that. So if you have, okay, well, I can use this example we are using already. So the cross join actually returns the Cartesian product of both tables. Every row from the first table paired with every row from the second table, right? And the syntax is select columns from table one, cross join table two. So here there's no basis to say you don't want to join in based on anything. It's just you pairing the both, like any doing all the possible pairing. And the use case is very rare, but it is used for generating combinations, e.g., assigning all customers to all orders for a hypothetical scenario or result. Maybe you want to carry out an experiment and you want to say, okay, what if Alice orders 250, Bob orders 250, Charlie orders 250, Alice orders 150, Bob orders 150. Like each of the three customers has each of the three orders. Maybe there's a situation for that you want to check, or maybe all the three customers actually come and they're like, okay, Alice comes and says, I want three packages, one of 250, one of 150, one of 300. Bob comes and says the same. Charlie comes and says the same. So that's a very nice example of cross join, right? So you have three packages and then you have three customers. So if you have four customers, it's also like all the four customers they come to want each of the three packages. That's the scenario for cross join, right? So cross join, of course, SQLite supports cross join. So now, having given the background of that, so let's go to where we now begin to use Python to execute these joins. Now, in regular SQL environment, not Python, Or maybe I don't know if maybe SQL Alchemy has actually gets that done, or my SQL like that. But in regular SQL environments, all these things are possible. But for SQLite, we have to work around some of things that do not exist in SQLite. So using Python to execute joins now. So we'll use the built-in SQLite 3 Python module to create tables, insert sample data, execute join queries, and fetch combined data results. All right. It's all about joining tables. So set one, I mean, the setup, you want to create tables and insert sample data. So of course you import SQLite 3, which is already built in Python, so you don't have to install it. And for the first time, we are bringing up the idea of a demo. You want to connect to SQLite in-memory database. So there's an in-memory database in SQLite, and it is used for demonstration. And you use file database as needed. All right. So if you have another database file, you can easily use it here. You know, we have been doing that a lot. Like when you create a database and you put information into it. But we have this inbuilt memory where we don't have to create any database anymore. You don't. So if you go into this place now, even after running this, you won't see anything like memory because it is inbuilt in Python. So you just want to connect to that in-memory database. So connect SQLite3.connect instead of having your own name database.db. You just have this full colon memory full colon, and then you create a cursor. You have connect to the cursor, and then you create customer stable because you need the cursor for that. So you have cursor.execute. So this is a regular SQL statement, lots like we saw at the top now. So you just create table customers, customer ID, integer primary key, name, text not null. All right. And then you now have, so here now, you don't have to create a database. So, but you are creating a table to put into that database. So it's used for demonstration, right? So for without you having to create an external database like we've been doing so far. So we want to create a customers table with customer ID and name. The customer ID is integer is a primary key, right? And then the name is text, not null. Then we want to create an orders table. So you say cursors.execute, create table called orders with order ID, customer ID, and then you now need an amount, right? Of since they are placing an order. Now there's a special thing here. You know, the order ID here is also primary key, but then the foreign key is the customer ID, and that references the customer ID in the customers table. So this is very necessary to establish the possibility of making connections. So, and here we want to insert a sample data into customers. So you have customers, one Alice, two Bob, three Charlie. So these are the three customers. And then because we want to do many, so you say customer.execute many, then you now say insert into customers the values. So you put the placeholders and then the customers, you call that we can this is like a Python list, right? And then you have customers, and then you can now insert sample data into orders. You want to insert sample data into orders. So for the orders now, so you just call it orders. So you have 101, 250, 1022, 150, 103, 4, 300. Of course, you know that's order ID, customer ID, and amount. So customer ID 4 does not exist in customers. I think we saw that before. And then now say cursor.execute menu, insert into orders, So it's the table called orders, the values with three placeholders now, because you need order ID, customer ID, and the amount. And then the orders you declare there in line 30. So you put it here, and that is how you create. So here alone, we are not creating a database, but we are creating two tables to put into the in-memory database on SQLite. So by just running this now, it hasn't been run because this is blank. But if I run this now, number one shows up there. So it means those tables have been created and those information have been put into the tables, which are in the in-memory database called memory, right? So the next thing is when I want to begin to do the different joins, inner join. So you want to retrieve customers who have placed orders, right? So the customers and with their known orders, right? That's what this does for you. So what you do is you have query underscore inner, and then you say select customers from the customers, their names from. So this is the table name now, and this is the column you are selecting. So customers name, orders amount from customers. All right. So you inner join. Uh, so you are joining customers to orders based on customer ID. The customer ID in customers equals the customer ID in orders. That's what we are doing. So we are matching the names with the amounts. because we need only the customers that have placed orders in particular. So you now say cursor that executes query inner. So this query you have created here now, you now call it, and then you for the rows you cursor.fetch all to bring out all the rows that match this query inner. So you now say for row in rows, you print customer. So you print the customer name and their order amount in row 0 and row 1 like that. So we run this, and this is what we get, just like we saw in that table before. So Alice 250, Bob 150. That was the very first thing we saw here. Alice 250, Bob 150, like that. So that is for inner join. That's where you have that's like intersection of the two tables. Then we have the left join. Here you retrieve all customers with their orders, including customers without orders, right? So as far as so you want all the customers, you don't care whether they have ordered or not. That's what this is for. So it's a query left, and then you have the SQL statement. It's a SQL query from lines 2 to 4. So select customers.name, orders.amount. So name from name column from the customers table, amounts column from the orders table, and then from customers left join orders on customers dot customer ID equals orders dot customer ID. So this customer ID is what connects the two tables together. Then you do the usual thing, cursor.execute query left. This query left here, rows is equal to cursor.fetch all. For row in rows, you print f customer row 0 order amounts. So you have all the customers and you have their orders. So if the order does not exist, you just put null. So you run this, and that is what we get. Okay. So you have Alice, Bob, and Charlie. Alice order is 250, Bob order is 150. Charlie on the table, on the second table, there's an order who, and we don't know the customer. So, but as far as Charlie is concerned, the order number does not, the customer ID does not match that third order. So, if you say this is none or null in Python parlance, right? Or is it SQL parlance, right? So, then we come here 5.3.4. Now, right join does not SQL does not support SQLite does not support right join. So what we do is we simulate right join using left join, and what we do is we now switch the columns. So you see what we did up here. So we said select customer name, custom orders amount. That still works. First line works, but we now say so. You know what we did before? You said from customers left join orders on customer ID, blah blah. So the only thing that is changing now, instead of saying from customers and join from customer left join orders, you still use left join. You say from it will now be from orders left join customer. So it's more like you're switching the tables over, so you can still achieve your left join. And so either way, you still have your result. So it's before from here it's from customers left join orders, but here it's from orders left join customers. So those SQLite does not support right join, but you can use left join and switch the tables, and every other thing is the way it is. So and that way now we can now say so. But there's also something here. So instead of just saying row 0, so you have the row 0 or null. So if the row 0 exists, fine. If it doesn't exist, null. Then order amount, we have all of that going on there. And with that, now we have at least we have all the orders 250, 150, 300. But then we know 250 matches with Alice, 150 matches with Bob. 300, we don't know we don't have the customer name in the table, so that will be null. So not unknown customer with 300, an order of 300. So though SQL does not support right join, but you can make so you can see we still use the left join, but we just switch the tables basically. All right. So another one is you can simulate full outer join in SQLite, right? SQLite does not support full outer join. You know, full outer join is you want to see everything in first table and second table, whether maybe we want to see all the customers, whether they have order or not. I want to see all the orders, whether they have whether we know the customers that place the orders or not. That's what full join does. Full outer join. All right. So simulate full outer join is SQLite. So SQLite does not support full outer join, but it can be simulated using a union of left join and right join, right? So since SQLite lacks right join, we simulate it by swapping the tables in a left join, just like what we did before. So see what happens here. So query full order now. So you have this is what we used for left join. This is the normal thing for right join. So customer name orders amount from customers left join orders on customers the customer blah blah. We've done this before. So we're just doing a union of this and this now. So it's more like we are merging this together, this and this. We are merging them together. So when we do that, right, we have all the customers and all the orders where there's no match, we have null there. So if I run this now, you see we have okay, it doesn't even follow a particular order. We have Alice with 250, Bob with 150. We have an order of 300. We don't know the customer. We have Charlie. We don't know Charlie's order, basically. So that's what full outer join is. Okay. Then we also have cross join in SQLite. Of course, like I said, cross join is matching, pairing up all the possible customers with all the possible orders. Basically, that's what cross-join does. Thankfully, SQLite supports this, so you can perform cross-join. So here we say query underscore cross. So select customer name orders amount from orders cross-join customers. So here we don't have to do it. We've always done this on orders.customer ID equals customer ID. Here we don't have to worry about that because we want to do all the possible pairings. So it's not restricted by foreign key or primary key. Now it's all customers, all orders, or depending on the kind of tables you're talking about. Then we do the normal cursor.execute query underscore cross. Rows is cursor.fetch all. Then fetch and print results. So the results is cursor.fetch all, right? And then for row in rows, you say customer. So for customer in row one, order amount, you have that in row zero, you have this in row one, like that. Okay, so we just run this and we have all the possibilities. So if you have three, since we have three people, three customers and three orders, so that'll be 3 by 3. So if you have four customers and three orders, to be 4 times 3, 12. So here Alice can have an order of 250. But so it's like I said before, you have each customer ordering the three available packages. So that's the scenario of cross join, like that. So um okay, so then in summary, right, you see that inner join returns only matching rows between two tables. That's intersection in set theory. Then you have left join, which returns all rows from the left table and matched rows from the right. So this looks close to something like difference of sets, but not quite, because because in difference of sets, if you are doing left join, everything in the right will be deleted, but that doesn't really work here. So right join returns all rows from the right table matched rows from the left. And this is not possible in SQL, but we can use left join and switch the tables, right? Then full outer join returns all rows with matches where possible. And it is we can simulate this in SQLite by taking a union of both left and right join. Then we have full outer join, which returns all rows with matches where possible, simulated in SQLite. Is that not what I just said? No, yeah, I think that's what I just said. So right join doesn't work, but we can use left join and switch the tables. Full outer join, we find the union of left and right joins to simulate. Cross join returns 3 customers by 3 orders, which is equal to 9 rows, pairing every customer with every order. So then we can use appropriate joins to avoid unnecessary data. For example, avoid full join or cross join on large tables unless needed. So imagine you have a table containing 100 customers and say 100 orders. Can you imagine that? If you do full join for that, that's going to be a whole lot, right? Maybe full join is even still uh, a full join is still a bit friendly, but cross join is going to be totally out of it because you're going to have like 100 by 100. So you're going to have a database, a table that is so large that I don't know, it depends on your situation. So you want to be careful of using things like full join or cross join if it's totally not needed, you don't want to bother about it. So be cautious with nulls in join conditions as they don't match any value. So if you have nulls and you are trying to join, so be sure that they don't join because they don't match anything. So be sure what you're working on. So using Python with SQLite 3, we can execute these joins and fetch combined results easily. Of course, for production or larger systems, you can use the full feature database like PostgreSQL or MySQL and corresponding Python connectors. All right. But don't forget that SQLite is the most used SQL platform, right? So because that's what you have in most of the phones you carry around. All right. So with this, we come to the end of this video. Let me know how helpful this is for you. And if there's an idea you'd like me to implement, feel very free to let me know. I'll be able to pull that off. If you have subscribed, you know you're enjoying a lot already. If you have not subscribed, of course, you want to do that right away so you can be part of, so you can learn a lot from this channel. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. So we have a special privilege these days for uh, those who want to be channel members. So you have three packages, right? I mean, increase it to four. But once I identify a high level of benefit, so as a member, you have some special privileges. You may be the first to see some videos. You may be you may I can make some videos exclusively for only members. Because they are so part of the privileges. I think for a level of the membership you can have access, like if you're interested in maths, you can have access to my PDF notes of the maths teachings I do. Then if you're a member of I have three levels now. I have bronze, silver, and gold accesses. So if you're a gold access member, we can have one-on-one connections. We can discuss whatever is of interest to you, and so on and so forth. All right, so you want to check those out and be sure to like and share. But if you don't become a member, no problem. All the privileges you've been getting before you continue to get them, not a problem at all, right? Um, then like and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing data right. In the next video, we'll still be talking about working with multiple tables, where we talk about things like group by, aggregate, and all of that. Keep doing data right, like I said. Bye.